So construction materials. Construction materials and materials. This is just a PowerPoint presentation. Since you have your study pack, you can jot down what you don't have inside your study pack. So construction materials, they are just materials that are being used for construction of buildings. And most times when we talk about construction, people think we only talk about building, of which construction has so many aspects, and what we construct differs. So aside from buildings, we construct structures too, like dams, retaining wall, roads, bridges, and all that. Please, before I continue, if you have any question, I'm going to give room for question at the end of every lecture notes so that you can actually ask your questions. And talking about construction materials, some materials are naturally occurring, while some are man-made products. Some are biodegradable, while some are perishable. Some are sourced locally, while some are sourced, globally. Those are construction materials. So for example, we have different examples of construction materials. So we are going to talk, those construction materials, but we are going to be talking about the construction materials and their properties, or we can call them their characteristics. Because in exam or for any other purpose, it might be construction materials and their properties, or construction materials and their characteristics. So stone, or let me say natural occurring rocks. When rocks are being broken, they can be broken down to stones. And something about stones, they've been used. These are the pictures I have here in figure 2. You can see items, different items that have been built from stone. Stones are very difficult to work with. And because of that, because they are very difficult to work with, it's labor intensive. And because it is labor intensive, it is expensive. So some rocks are used as raw materials in the production of other building materials, such as cement, such as lime. By the time they are producing cement, they have to use a particular stone, limestone, that is our CaCO3. So some stones are durable, resistant to weather, and have beautiful external surfaces. So these are some of the pictures. We all know what we use stones to do, but these are some of the pictures of what we can actually come out, or of what we can actually build from stone. So if we are asked to name probably an example of a construction material and their properties or characteristics, I will expect you to talk about stone in this way. Also, don't forget, we have 3 principal, because we said stones are being gotten from crushed rocks, So we have 3 principal classes of rocks, which I know we all know. So it's just like a revision class. I'm very sure we know that we have igneous rocks, examples of which are plutonic, examples of which are, volcanics. So aside from igneous rocks, I know that that we have sedimentary rocks like sandstone, like limestone. Sandstone, they are porous, that is, they are prone to dampness. And we have what? Limestones. Please, are we together in this class?
Yes, we are. We are hearing you.
Okay, thank you. So I've talked about the 2 types of rocks. I've talked about the igneous rock. I've talked about the sedimentary rocks. And then the third one will be the metamorphic rocks. The metamorphic example of that is what? Marble and slates. For example, part of my figure 2, this kitchen top was finished with marble. So that is one good thing that we can use stone to do. Marble is an example of a metamorphic rock. It's very expensive because it's for luxury. It's luxurious, so it's very, very expensive. And another example of metamorphic rock is slate, which is made from compressed clay or shale. So those are some of the properties of stone. So let's look at another example of a construction material. Another construction material that we have is concrete. We all know, in fact, I think that is the most important construction material that everyone knows, concrete. And what is concrete? The mixture of cement, sand, gravel, and water, which sometimes we call, instead of calling it cement, we call it fine aggregates. Instead of calling gravel, we call it coarse aggregate. And of course, water. Water must be present so that hydration process can take place. Now, before I continue with concrete, there's a difference between concrete and mortar, because in construction work, sometimes it is not all the time that we use concrete. We know concrete is a mixture of cement, sand, gravel, and water, while mortar is a mixture of cement, sand, and water. There is no gravel, or let me say there is no coarse aggregate in mortar. We use mortar for plastering, rendering, depending on where you are doing the work in the house. Is it inside the house or is it outside the house? We don't use concrete to plaster, and we don't use concrete to render. So now back to concrete. We said it's a mixture of cement, sand, gravel, and water. So when we allow our cement to harden over time, it assumes a rock-like form in hardness. It becomes hard because by the time you mix it with water, it passes through different stages. It will first be a fresh concrete when it can still flow. You know, it is until when it becomes hardened that we now say, okay, we have concrete. Now, for technical reasons, we said it is not good for concrete to be very wet. Though when concrete is very wet, it is workable. And what do I mean by workable? It is very, very easy to work with, you know. However, the more water you put into your concrete, the reduced strength you are going to have. So we know that more water in cement causes reduction in the strength of your concrete, even though it's going to be more workable, but it's going to reduce the strength. And when you have more water in your concrete, aside from the fact that your strength is going to be reduced, there will be increase in the number of pores. You know, you are going to see so many pores on the surface of your, we can call it honeycombs too. You are going to see it on the surface of your concrete. Now, there's something we call, the last point there says the ratio between the weight of water and that of cement in concrete is known as water-cement ratio. Yes, there's something we call water-to-cement ratio. It comes in, you can have 0.4, 0.5, 0.6. But the whole essence of this water-cement ratio is the higher your water-cement ratio, the lower the strength. For example, in your concrete, a water-cement ratio of 0.4, if you use a water-cement ratio of 0.4, it's going to come out, the concrete that will come out from it is going to be stronger than when you have when you use a water-cement ratio of probably 0.6, 0.7. So it goes just like that. Now, sometimes, truly by the time you are mixing your concrete, it might not, if you put 0.4 water cement, if the ratio of your water cement there is 0.4, truly it might not be easy to work with. You might still notice that your concrete needs, you know, water to be able to mix it very well or make it more workable. That is when you now need things that we call admixtures. Admixtures are added into concrete in order to modify their properties. So one example, instead of using more water, a good example of admixture that you can use is called plasticizer. You can get them from those chemical industries and all that. So we have plasticizers that we put inside our concrete to cater for, you know, water, as in to prevent us from adding too much water. And of course, we know what we use our concrete to do. For example, in figure 3, we see concrete floor. We know what concrete floor is. So I think that is not a problem. So the third construction material I'm going to be talking about is what? Is plastic. Plastic. See figure 4, we have different items. You know, we use plastic, we can use it for some plates we use in the kitchen and all that. You know, they consist of molecules joined together . Thermoplastics and we have thermosets. You know, thermoplastics, they can be soft-toned and re-soft-toned repeatedly by heating, provided the material is not heated to a level that it will cause its degradation. And we have we have thermosets. Usually once they set and hardened, you know, they cannot be broken down again. Unlike thermoplastic that you can apply it, you can mold them into another thing, you can remold them and apply on. So thermoset is just like the opposite of a thermoplastic that you can easily work with. So another example of, okay, and before I leave, plastic, let me say some things about plastic. Plastic, they are reasonable in cost. They are not too costly, resistant to corrosion. They are highly resistant to corrosion. They are lightweight. However, they are tough. They can be easily molded into different and complex shapes, and their maintenance is very low. They have low maintenance requirements. So we've talked about thermoplastic and we've talked about thermosets. So timber, I'm sure we all know timber. However, this is what I want to point out. After concrete, that is, let me say, the most known construction material, another material that people know very well is timber, because we use it in so many areas in house, for doors, for windows, for chairs, just name it. We all know what we use our timber to do. However, when a tree is being felled, that is when a tree is being cut, you know, at that point, we call it wood. But by the time those woods, they are not timber at that point. When they are being felled from the bush and, you know, being transferred, they are still wood. But by the time they are sawn into different sizes and they are treated, what I mean by treated is they are being seasoned. What do you understand by seasoning? Seasoning means a removal of moisture from our wood. That is when we can now say, okay, we have a timber after it has gone through that process of seasoning. And I'm sure we know that we have different types of seasoning methods. However, the most common ones are what? Air seasoning and kiln seasoning. Kiln, in the spelling of kiln is K-I-L-N. That N is silent. So we have air seasoning and kiln seasoning. The difference between air and kiln is because for air seasoning, after the wood has been cut and all that, to undergo the process of seasoning, they will just stack it open shed, so that air that is coming, you know, will blow it and will dry the moisture away from it. But when we are talking about the kiln seasoning, it means you are going to use a sophisticated, you know, equipment, and it, of course, it requires specialists because you are using sophisticated equipment. It requires specialists, and it is definitely just pack in open shed so that normal natural hair will dry it. So we have the two common ones, though we have other types that are not common. We have the hair and we have the kiln. That is what we call, you know, seasoning of your timber. However, back to our presentation, timber can be classified into two main groups. We have the softwood and we have the hardwood. We have the softwood and we have the hardwood. So what do we understand by softwood? Or how do we differentiate softwoods from the hardwoods? Another name for softwood is gymnosperms, while the hardwoods are angiosperms. For the softwoods, they are derived from cone-bearing trees of the coniferal family, characterized by their needle-like leaves and naked seeds. Softwoods, they are also resilient and they do not accept finishes. But hardwood, they have broad-leaved trees. Of course, they are stronger than the softwoods and they accept finishes. And maybe that is what makes them more expensive. You know, they are resistant to scratching, to denting, and they better accept finishes. So examples of softwoods, we have Afara. These are the names that we are familiar with. Because I said this class is something we all know. So it's just to refresh in our memory. So we have Afara, Iroko, Apple, Cedar, and all that. And for the hardwoods, we have Opepe, Sapele, Ebony, Camwood, Achi, Obeche, Mahogany, and all that. So that is that about timber. So another thing I want to talk about is another construction material we want to talk about is the bituminous material. Because when we are talking bituminous material, I'm very sure we know what bituminous materials are, especially, you know, for road construction. We know we have asphalt, we know we have bitumen, and we know, you see, I'm sure we've seen where road construction, or we've even participated in road construction before. So bitumen is a mixture of natural hydrocarbons and their non-metallic derivatives. It may exist as gas, liquid, viscous liquids, or solids. But the most important thing is we have two main sources of bituminous materials. We have natural asphalt and artificial sources, that is the petroleum asphalt. You know, bituminous material, they are used for the following purposes. We can use them in highway that we know. They can be used as waterproofing or insulating materials, and they can be used for road improvement and maintenance. I'm very sure we are all conversant with all this. So another example of construction material that we are going to be talking about is glass. We know glass. Glass are being produced by fusing together soda, lime, silica, and other minor ingredients. That is glass. So we have different types of glass, you know, and something about glass is they allow passage of light to pass through them. They do not conduct electricity. They are corrosion resistant. They do not conduct electricity. They allow lights to pass through them. They are corrosion resistant. Now we have different types of glass, which is very important for us to know. We have clear floats. I have some examples of or pictures of some types of glass that we have. You know, the kind of glass that we use in the living room is different from the one that we are going to use in our bedrooms. You understand? The ones that we use in our bedrooms are translucent glass. They are patterned glass, so that there's nobody that is going to see through them, unlike the one we have in our living room. You know, so we have clear flow. I'm sure we have our study pack, so we can actually go back to our study pack, yes, and, you know, go through the notes. We have our clear float. We should know that we have our clear float. We have our clear. We have a translucent glass. These are pattern glasses. You know, they are patterned, so they are not transparent. They're just as the name implies. We have a wired glass. So please, I want you to read these particular types of glass very, very well. So our choice of glass. So what are the things we are going to consider when we want to choose, you know, our glass? One, do we need our privacy? Of course, if you need your privacy, it means you're not going to go for a clear glass. Do you require clear vision? Because if you require clear vision, it means you're not going for what, a translucent or, you know, a wired one. Is it security? Is it resistance to wind or loading? If it is clear float is just like it's just a flat glass, you know. And of course, you are going to consider, because they have different thickness. You are going to consider the thickness so that you will know which one. For example, for the clear sheet, the thickness ranges between 3 mm to 6 mm. For clear float, it ranges between 3 mm to 25 mm, and so also others. So you have to consider the thickness so that you will know which one you really need for, you know, for security purpose, fire resistance, aesthetics, clear vision, resistance to wind loadings, and all that. Now, so there's a difference between glass and glazing. You know, don't forget, we said glass, they are materials produced. So you should be able to say, or you should be able to note the difference between, what if I ask, what is the difference between glass and glazing? So there's a difference between glass. Glass are materials produced by fusing together soda, lime, silica, and other minor ingredients, while glazing is the act of fixing the glass into a frame or surrounding. Glazing is the act of fixing the glass into a frame or surrounding. And don't forget, we have, by the time you have those glasses, you can't just put them on the floor and say, okay, you have to fix them somewhere. So the act of fixing those glasses somewhere, probably you are using a frame or you are using a surrounding, is what we call glazing. So now, your glazing can be a single layer. You understand? A single layer of glass, when you just pick a glass and you fix it in a frame. Or you can use a double glazing, depending on the thickness you want. That is when you're now using, it's just as the name implies, when you're now using 2 layers of glass instead of just a single layer. So, but the moment you know what your glass is and what your glazing is, whether it is single layer, whether it is double layer, you will be able to, work with that. So, but I talked about fixing them into a frame or surrounding. So we have 2 major frame or surroundings for our glass. We have a timber frame and we have a metal frame. So for example, types of glazing surround. I'm sure you can see the first one that has the timber frame or the timber surround, and the second one that has a metal frame or the metal surround. And the difference between the two the difference between the 2 types of surround are what we have underneath. For the timber, it requires more maintenance than metal. It can last 50+ years if you use a very good wood. You can paint it, if your house is green and you use a timber surround or a timber frame, you can actually paint it to the color of your house or anything just to match your preference. It could be expensive if you use a very hard wood. However, for metal surround is what we call aluminum. It's very light and strong, you understand? So those are just the difference between the 2 types of glazing surround, the timber and the metal surround. Please, are we still together?
Yes, we are.
Yes, we are.
Thank you. I just want to know the audio is good today. So another type of material, we are still on construction. We have so many construction materials, but we all know. But for the purpose of exam and for the class, we can't take all, but we are going to take some of those construction materials. So another one is metal. We all know metal. Metals, we know we have ferrous metals and non-ferrous metals. Something we all know. So for the ferrous metals, of course, metals are strong, they are decorative, they are conductor of heat and electricity. We all know that. So we have examples of ferrous metals and we have examples of a non-ferrous metal. For the ferrous metal, we know we have cast irons, we have wrought irons, we have mild steel, we have stainless steel. And for the non-ferrous metal, the most common example of non-ferrous metal type that everybody knows is aluminum. But aluminum is not the only example of a non-ferrous metal. We have aluminum, we have copper, we have tin, we have lead, we have zinc, we have silver, brass, gold, bronze, and all that. Now, why do we call some ferrous? Why do we call some non-ferrous? Ferrous because it contains iron. Iron, our Fe, that's the symbol. Ferrous because it contains iron, and non-ferrous because no iron is present. So the ferrous metal, aside from the properties that we have on the screen, ferrous metal attracts, magnets, while the non-ferrous does not attract magnets. And because the ferrous contains iron, they are prone to corrosion. Because they oxidize, they are prone to corrosion. these are the examples of non-ferrous, you know, and these are the different things you can use them for. We have the aluminum, which is lightweight, copper, brass, lead, bronze. They have different purposes, you know, because they have different characteristics. So why is aluminum, which is an example of non-ferrous, I think aluminum is even or let me say widely known as an example of non-ferrous. It's a versatile material, you know, it's lightweight, and that is why we use it in our cooking at home. It is lightweight, it has low melting point, it's a good conductor of electricity. It can be, all this aluminum, especially all these non-ferrous, they can be strengthened by alloying or cold working. So that is now, so those are the examples of few of the construction materials that we have. Now, these construction materials, they have factors that affect them. They have factors that affect them. However, for the scope of this lecture, we are only going to be consider climatic condition. Now, this particular course, building construction, in case you know we are writing the exam and I don't expect word for word, because this is something we all know. I don't expect you to write my own word for word or what is inside the study part. You can actually put things in your own words, because these are the things that we know. For example, how does a climatic condition affect construction materials? You know, because what are the climatic conditions that we have? We have rainfall, we have temperature, we have humidity. So in your own words, you actually know how rainfall can affect construction materials. For example, you know, by the time you put your cement or your wood or timber under the rain, we know what it can cause. So without being told, you can actually put things in your own words. And aside from this climatic condition, you know, I said there are other factors that can affect our construction material. We have, you know, the storage, the quality can affect construction material, the availability, the cost, ease of transportation. All those factors can affect our construction material. However, we are only going to be talking about the climatic conditions, that is the rainfall, the temperature, and the humidity. For high temperature, the strength development of concrete is adversely affected during the early stage of setting and hardening. When there's high temperature and you are mixing your concrete, somehow it tends to quickly remove, you know, water from the concrete you are mixing, and therefore it can affect the workability of your concrete, because the temperature is high compared to when, you know, when the temperature is not that high. You understand? The concrete will still retain its water. It will give you more time, you know, to work with the concrete. So high temperature has adverse effects on your concrete, especially at the early stage. Then another thing is, owing to high temperature, fresh concrete loses rapidly some of its water. Like I said, it affects workability, making transportation placement. What do I mean by I said workability means the ease of mixing your concrete. What do I mean by placement? The process of pouring your wet concrete inside your mold or formwork. I know we all know what I'm talking about. It's either you use mold or it's either you use formwork. Your formwork can be made with metal. Your formwork can be made with what? Wood or timber. And of course, by the time you see the screen says the workability of the concrete, making transportation and placement difficult, and by extension, the compaction is also affected. What do we mean by compaction? Compaction means the process of removing air or void from the concrete you've already poured inside your mold. And in some construction work that is not that big, you'll see that immediately they pour their concrete, they will pick a stick and they will start tapping it. While in big construction companies or for big construction works, they use better compaction material, like, you know, electric vibrator to remove air or void from the concrete you poured. So also your high relative humidity. You know, I've talked about rainfall. We all know what rainfall can do to our construction materials. We've talked about high temperature, then humidity. Humidity will not really affect concrete, while humidity will have negative impact on timber, because that one can easily absorb. Humidity will not have any impact on your hardened concrete, though it can have impact on your cement if you've not used it, you know, but it cannot have impact on already hardened concrete, but it will have great impact on your timber. It can have great impact on steel. So that is humidity. So I expect us to know how these factors affect construction materials. Please, is there any question before I continue to topic 2? Do we have any question? I should continue.
No question for my end.
Question?
None at the moment, ma'am.
Okay. Okay. I can continue to our topic 2, which is maintenance management. Maintenance management. So, maintenance is a very important topic, let me say, even in our country, because we really don't have that maintenance culture. However, there's no how you can have your building or your structures and you shouldn't talk about maintenance, and probably that is why we are talking about this maintenance management. So what do we understand by maintenance? Maintenance can be defined as work done to keep a building in or restore it to a currently acceptable standard. So no matter how good a structural engineer has designed a particular building, no matter how good a builder has built or supervised a particular building, if the building is not being maintained, it's not going to, because everything has its useful lifespan. So if they are not being maintained, even road, any structure for that matter, if they are not being maintained, they are not going to stay up to their proposed useful lifespan. But I say this, we don't have that maintenance culture in Nigeria. So you can see in figure 10, or let me say we are now developing it. So we can see in figure 10, we can see so many, in fact, these buildings we are looking at in figure 10, I'm sure we've seen a lot of these buildings that are showing they're already showing signs of distress, Probably these buildings were not maintained well, due to so many factors. These buildings, they might not even have lived up to their, useful lifespan, but because they are not being maintained, you understand, so they will quickly they will quickly show signs of distress. And by the time and for a building, in fact, we hear about building collapse all over the country. Most buildings, I'm not talking about the ones that they are just constructing and probably they didn't use good material and, poor workmanship and all that. They are not using skilled or experts. Some buildings that have been existing, they will not just collapse in one day. They would have been showing signs, probably cracks here and there, and there's nobody to come up and do the maintenance work. And that is why we have, so you can see in figure 10, buildings showing lack of maintenance for a very long time. So, and some buildings, you will see them, one part is up, one part is down. They're already showing signs of settlement, which people don't pay attention to. They will allow it to sink until you just see it collapse one day. So what are the concepts of building maintenance? The building maintenance, okay, I'm coming. So these are the concepts of the building maintenance as consistently being an area of neglect for the construction industry. Then general lack of understanding of both its scope and its significance by all parties, starting from the procurement, the construction, and the management processes. After procuring, me, I've done my job. After constructing, I've done my, even the management, nobody cares. So that is just our culture here. Now we have different types of building maintenance. This particular aspect, I think, is very important for us to know. We have different types of building maintenance. We have planned. This building maintenance that we have, they are just as the name implies. They are just English words as the name implies. For example, the planned or scheduled. A scheduled, when the scheduled service or visit is being carried out by a competent personnel or agents. So planned maintenance, you've already planned it, you scheduled it. So the maintenance organized and carry out, you already have the forethought, the control, you can control and use records of a predetermined planned maintenance. We also have preventive. These types of maintenance, you should be able to know the difference between one and the other. For the preventive, as the name implies, preventive, to prevent. That is the key words are the words I highlighted using another color, I think the brown color. So the preventive, as the name implies, to prevent. As this is the maintenance. Are we still together? Are we still together?
Yes, ma'am.
Yes, ma'am.
Thank you, sir. Thank you. So the preventive maintenance, this is maintenance done at predetermined intervals. Predetermined intervals. Some people are joining us, and the background noise is affecting. So preventive maintenance, the maintenance done at predetermined intervals.
Mark, can you just mute them from your end?
It's the host that I'm not the host. I'm sure it's going to mute them. I'm not the host.
Mute it, please.
So can we continue?
Yes, ma'am.
Okay. So talking about the preventive maintenance, just as the name implies, the maintenance done at predetermined interval, interval, or the most important aspect of preventive is you are doing that maintenance to reduce the probability of failure or performance degradation of an item. That is, you are not waiting for that item to collapse. You are not waiting for that item to fail totally before you start something on it. You are not waiting for that item to fail totally before you start doing the maintenance. Just as the name implies, preventive. The first one, planned, something that you scheduled. You already have the forethought that, okay, I'm going to do this. It's kind of a routine maintenance. And for the preventive, you don't want to, you are trying to prevent. You are trying to prevent failure. You are trying to prevent collapse. And that is why you are carrying out that maintenance at predetermined interval. Let me say, okay, probably every 3 months, every 6 months, this is what we are going to be doing in order to prevent, cracks showing. Immediately you see a crack, you quickly rectify it. You don't allow the crack to widen up and become something else. So that is a preventive. Another type of building maintenance that we have predictive. Predictive is a regular periodic work that may be necessary to return the performance characteristics of a product, as well as that's required to replace or repair the product after it has achieved a useful lifespan. Predictive, to predict, You already you know what you have on your building, so you predict that, okay, this particular bulb, for example, I know it can actually it will last for, let me say, 6 months. So I know if I put it there in January, by July I should be getting ready to what, to replace it. So that is a predictive. You are predicting when the product needs replacement or repair. We also have proactive maintenance. I highlighted some words. That is maintenance. It's a maintenance strategy which prevents failure, maximize asset life and reliability. A maintenance strategy for stabilizing the reliability of any equipment. That is what we call a proactive. Then deferred, of course, you can defer something. I'm not doing this thing now, let me do it later. Just as the name implies, a deferred maintenance, this type of maintenance occurs when the maintenance problems are identified as necessary, but are put off. You've already seen that there's a problem, but probably maybe due to lack of resources and all that, you are saying, okay, I will defer it. I'm not doing it now. Let me do it later. You understand? So those are the types of building maintenance. We should be able to differentiate between one. We should be able to differentiate one from the other. So factors responsible for building collapse. They are the same factors that are responsible for building maintenance. I don't know if we are getting it, because these factors, they actually go hand in hand. For example, let's start from design factor. The design factor, I think that is the first thing we should talk about, or that is the preliminary thing before a building even comes into existence. So when we're talking about the design factor, these are the factors. I'm sure you have all these factors in your study pack. You can actually build on it and you can actually explain them in your own words. So far, the explanation is reasonable enough. So when we're talking about design, the first thing is you require competent designers, starting from the architects, but most people like cutting corners. Just because a structural engineer will ask you to bring this money, you think, what this man at the back of my house can do. And therefore, we start missing it from the design, from the design aspect. So another thing about design is, by the time you don't give it to competent people who can handle it, and you give it to probably quacks, as they are being called, there are so many things they won't take into consideration, because there's something we call, they might not assess the loading very well, because every building has, depending on what the purpose of that building, is it going to be residential? Is it going to be a warehouse? Is it going to, how many people do you think will be staying in this particular place? So we actually have different types of loading, which they should adequately assess at the design level. We have the dead load, we have the life load, we have the wind load, we have the dead load. Please, if at any point in time you can't hear me, please send a chat to me so that I will know you can't hear me. But as of now, I still assume we are all together. So talking about still at the design. So still at the design level, if you don't give it to competent people to handle the design, there are so many things they will start missing it. And by the time you are even doing your design, the moment you miss it from loading, you're already heading towards something else. So for the loading, I said.
Hello, ma.
Hello, ma.
Hello.
Hello. Can you still hear me? Can you still hear me?
Yes, we can hear you, but there is
Yes,
noise
we
in
can
the
hear you.
background.
Abdul Muritala, please mute, please. The lecturer cannot mute you because she's not the host. Abdul Muritala, please mute.
In background noise disturbing the lecture.
Okay. Let us have. Please, let us have this class today, please.
Hello, good morning. Please.
Hello, good morning. So please mute if you are still on mute. We need you to mute. So please, let's continue. At the design level, so I was talking about correct assessment of your loadings. And I said we have the different types of loadings. We have the dead load. That is, for example, dead load means the self-weight, the self-weight of the building itself. That is, we have different structural elements in our building. We have the slabs, we have the columns, we have the beams, you understand? We have different structural elements. Each element, all these elements, they have their own self-weight, their own weight, their own personal weight. Let me call it that. So the person that you are giving your work to at the design level, if they miss assessing the loading, and another thing is the life loads. We can call it life load, and we can call it imposed load. That is, those are the loads that are not permanent on the building. They are the loads. For example, I am a life load in this particular building. Wherever you are a life load because you are not stuck to the building. You can move out, you can come in. Your furnitures, anything we have in our house, they are not dead load because they are not part of the building own weight. They are life load, or I can call them imposed load. They can move, And of course, we have wind load. If you have a bungalow, the effect of wind is not going to be pronounced. Though wind is acting on your building, but the effect is not really going to be pronounced until you have, by the time you have 3-story, 4-story, and by the time you have, skyscrapers like that, then the effect of wind will come into play. So what I'm saying is, as the design factor that is responsible for building collapse or maintenance, it means, so I'm trying to explain that particular design factor, that is, give it to competent people. Lack of giving it to competent people will make them not to be able to access your loading. Some would not even be able to interpret the design drawings, that is the structural drawings or the architectural, because you start from the architectural drawing before you now have a structural drawing. Some will not be able to interpret your detailing. You understand? What are this reinforcement? Where are you going to put it? How are you going to put it and all that? Some people cannot. And by the time they will just carry reinforcement. I call it reinforcement and I can call it bars. I'm sure we know what I'm talking about. We have different diameters of that, and I'm not going into that because I know we know what I'm talking about. So they cannot interpret a drawing. And if you cannot interpret a drawing, what do you expect? They will just join them together anyhow, pour concrete, and we'll say, okay, the house is, standing and all that. Another factor that I have here is human or users factor. Back to us, we are the human, we are the users using these buildings. Our I don't care attitude. A building that is meant for two people to live in, 3 people, you will see so many people living in that building, a building where you are not meant to pound yam. You think, I don't care, at least I used my money to rent the house, But all those our attitudes have, effect on the building. And the building will be telling you little by little, but because we don't have maintenance culture, we don't even pay attention. You start seeing crack, you think, okay, it's nothing. You just remove face. Now you still continue with the habits, of little by little destroying, vandalism and all that. All those things, and a building that is meant for residents, you just decided, okay, let me be using it as warehouse to make more money. A building must be used for its intended purpose, because at the level of design, some things were taken into consideration that, okay, this particular building is a residential, it's not for warehouse. So by the time you convert it to warehouse, of course, there's going to be problem. Another thing is the environmental factor, as you can see on the screen. It refers to the effect of soil types, the climatic condition, vegetation. If you have a structure that is built on a firm foundation, and here, let me say, I'll be talking about the foundation. A building that is built on a good foundation, a foundation that is firm, that is well drained, it's not retaining water. You understand? You can't compare it with a building that is built on a swampy or a riverine area, and you're not even taking into and probably you didn't take into consideration.
Thank you. Good morning.
And probably you didn't take into consideration the foundation type of that particular place before you build before you have your building or your structure. Of course, it's going to be responsible for your building collapse. We know we have types of foundation. We know we have the shallow foundation. We know we have two types of foundation. We know we have the shallow foundation, and we know
what's wrong with this, Abdul? This is a lecture. What's happening?
We know we have two types of foundation. We know we have the shallow type. We know we have the deep foundation. Of course, when you're talking about your shallow foundation, if you have a shallow, the first thing, so it means you have to do your geotechnic assessment, even on the build. If that is not done, you will not be able to know the kind of foundation you have. You will not be able to know the type of soil you have on that building, so that you know the kind of foundation you are going to construct on that building. So climatic conditions too, because we are talking about environmental factor. Climatic conditions too. For example, when you don't have your DPM in place, that is your damp-proof membrane, water will just be seeping from the foundation up into your house. And that is why you see some areas very close to the floor of your house wet, because there's a problem. Water is seeping through into your house from the foundation. Probably your DPM, your damp-proofing membrane, has a problem.
Sorry, can we pause for a moment, please? Muritala, please mute. We can't hear any. Please. Oh my God.
So that is that about the other factors. Okay, I've talked about the design factors. We also have
Bluetooth mode.
We also have
FM mode.
our faulty construction or poor workmanship. So we also have our faulty construction or poor workmanship.
Have led to the imposition of curfew in many states. General Forsyth therefore the Nigerian Army to respond quickly and decisively to any attempt by elements or destabilizing agents to cause a breach of law and order. The National Agency for Food and Drug Administration and Control says it has
So we have our faulty construction or poor workmanship. I'm sure we know what that means. Lack of supervision during construction, failure to understand specifications and drawings, and all that. Then faulty materials too. When we are trying to cut corners, you should buy this type of material, but because it is too expensive and because they are not the one that will be staying in that building, you think, especially buildings given to developers, some developers anyway, not all, you think, well, I'm not going to be staying there. Your own aim is to maximize, profit and all that. So you buy substandard materials and all that. They are all at the end of the day going to affect the building, and they will be responsible for the building collapse and for the building collapse. So all these points, that is the design factor, the age of building, environmental factors, faulty construction or poor workmanship, faulty materials and all that, they are all the factors that we should know and we should be able to explain using our own words and explain well. So those are the factors that are responsible for our building collapse. Now, what are the components of building maintenance works? You know, we've talked about the types of building maintenance. We've talked about the types. Don't mix the types with the components. We talked about the types. We talked about the deferred maintenance. We talked about the proactive, the preventive, the planned, you know, and all that. Now, we're not talking about the components of building maintenance works. So what are the components? When we talk about servicing, what do we mean? When we talk about, I want to renovate the house, I want to rectify the house, I want to refurbish the house, what are we trying to say? So servicing, this is mainly a cleaning operation undertaken at regular interval. For example, sweeping the compound, removal of cobwebs. They are all, that is a service work. It's called servicing. They are cleaning operations that you do at regular interval, usually on a daily basis, day-to-day, things like that. Then when we talk about rectification, rectification is what? The remedy of shortcoming in design or construction, you know. For example, immediately you finish constructing the building and you notice some things. Before you open it to use, you know you have to rectify it so that they will not later become problems, you know, for the occupants or even for you, because everything will always bounce back. So servicing means a building that, okay, they've been living in, or they've been living in that building, and the day-to-day activities that you do, that is servicing. While rectification is the remedy of shortcomings in design. That is, a new building, after completing a building, you might still see some things that, okay, that are not supposed to be. So you try to rectify before you now allow occupants into that particular building. That is rectification. Then renovation. These are work done or alterations made to some part of building. You know, the building is in use. So once in a while, you want to renovate the house, you know, it's a common word that we use. We want to renovate our house. So they are just work done or alterations made to some part of the building in order to improve or restore it. You know, that is renovation. They are words that we are all conversant with. So we have retrofit, we have rectification. Okay, I've talked about rectification. Okay, rectification, that is to rectify, just as the name implies, to rectify or to correct errors or shortcomings. Now, so the retrofit essentially means fitting new and modern system into an existing building. Probably you have this type of design and you think, I went to my friend's house yesterday and they have, if you see how they constructed their, you know, their kitchen and all that, you want a modern, because, you know, the world evolve. What you use in year 2020, what we are using now that we think is the latest, by the time maybe in 10 years time, it might be I'm sure it will be outdated. So you need to introduce new material or new structure or a new system, new fittings into your house. So that is retrofit. That is, you are fitting new and modern system into an existing building. So refurbishment and rectification, sometimes they are words that you can use because they mean the same thing. It entails extensive repair, renewal, modification of a building to meet economic or functional criteria equivalent to those required of a new building. The replacement, of course, we know replacement, it means to replace. This thing is not good, this bulb is not good, I can replace it, you know? So those are the components. So the components of building maintenance work are servicing, rectification, renovation, replacement, refurbishment. They are different from types of building maintenance. So the third topic I'm going to stop talking about is maintenance budget. Now, everything you want to do requires money. Money answer it, if not all, maybe some, the normal saying. So maintenance budget. What do we understand by budget? A maintenance budget can be defined as a cost projection. This figure 11 is just showing a pie chart of a budget that is, okay, this is what I'm going to allocate to this particular area, depending on the need of that area. So a maintenance budget can be defined as a cost projection based on the cost of labor, equipment, material, and other items. So a budget to show how much or the quantum of need of which department. Because if we are looking at this figure 11, me looking at it, I can see that the red part of my pie chart means little budget is being allocated for that purpose, while the sky blue part is showing that a larger part of my budget is going to, so your maintenance budget is going to show how much is going to be needed in this department, how much is going to be, depending on their, on their job descriptions and on what they carried out. So that about maintenance budget. It is based on demand too. Somebody that you don't have to give much to somebody that doesn't need it. You have to be able to allocate your resources very, very well. And of course, your maintenance budget should come under the main headings, 4 main headings. That is the labor. Labor is very important. The material, your tools, and your maybe resources, that is the contracted services. So, and we have 4 budgeting methods. We have 4 budgeting methods. We have the incremental, we have activity-based budget, we have zero-based budget, and we have value proposition budgets. These ones are just by the way. They are just by the way. And we have 3 types of budgets. I'm sure we all know that we can have a balanced budget when your estimated expenditure is equal to your expected income or revenue. It's balanced. What is here is the same thing as what is here. What is coming in is the same thing as what you are going to expend. And of course, you have surplus. You can have surplus type of budget. That is surplus in the sense that what you are expecting is more than what you are going to spend. That is, you have your expected revenue or income is greater than your estimated expenditure. Just as in, and of course, deficit. Deficit is just the opposite of surplus. When something is surplus, it's to your own gain. You're not going to be spending much. But when you have deficit too, well, it means you have more demand. So that is the estimated expenditure is greater than the estimated revenue. So that is our. So those are the 3 types of budgets that we have: the balanced budget, surplus budget, and the deficit budget. Now, for every organization,
where did you get your story pack?
For every organization,
No, I'm not doing those.
Suliat, please mute yourself.
For every organization, they have someone. Of course, someone is going to be in charge of budgeting. It is not the CEO that will be in charge of budgeting. Somebody is going to be in charge of budgeting. So, if you are going to be, this is just tips for a new budget manager. This is just tip for a new budget manager. You have to invest time to learn.
Your microphone is muted.
You have to invest time to learn from the start. As if you are going to take up that role, you have to invest time to learn from the start. Of course, you would have taken relevant courses in finance and budgeting. You have to be a team player. You know, you have to be transparent. If you are going to be a budget manager, you have to be someone that can be trusted, someone that is transparent, someone that is reliable, someone that people can say, okay, anything he does, we are very sure, you know, because you've already carried them along. There's nothing shady about what you are doing. Now, this is important. Functions of maintenance supervisor or officer. You must know the function of a maintenance supervisor or officer, and you must know their challenges, because every office comes with its own pros and cons. So what are the functions of a maintenance supervisor? Is responsible for monitoring expenditure against the budget for the year, responsible for its yearly updates, because what they use this year might be different. The budget they used last year might be different from what they are going to use this year. So he must be able to what? Update, you know. Then most times, especially if you are not working in let me say in an engineering-based office, sometimes your CEO might just be, you are the maintenance, a maintenance officer. Your boss up there might not really study anything on maintenance. So by the time you are telling him, sir, we need this year, we need this year, he might not even understand what you are saying. So you have to give proper awareness to management of the importance of maintenance. You know, by the time you tell them you want to do maintenance this today, you want to do it, they might be telling you, what do we really need this for? So as a maintenance supervisor or officer, you really need to be in charge to explain to them why you need this and what. So those are part of the challenges you might be facing, because maintenance personnel experience difficulties in determining the maintenance standard of the building because of inadequate maintenance resources allocated from top management. They don't really understand what you need so much money for. So you have to be able to break it down for them so that they will reason and they will know, okay, truly you need this particular money to do all this. So organizational and maintenance objectives sometimes are not properly understood at the top management level. Therefore, allocation of maintenance resources is insufficient to meet needs. So you as the supervisor or as the officer, you have to know your functions, and you have to brace up for the challenges that you can encounter while carrying out your work. Do we have any question before I start my lecture notes 2? Do we have any question, or I should continue?
Please, where more? Please,
Ma,
where more the challenges, ma?
Please, ma, I have question, please.
Okay.
So should I ask the question, please?
Yes. Yes, you can.
Yeah. Please, ma, this your short and direct, so summarized this thing. Can we please have it in form of, in addition to the books we have, so that will go a long way in assisting us towards.
But do you have your study pack, sir? Do you have your study pack?
Yeah.
Okay. If you have, because your study pack too is important. If you have your study pack, at the end of this, maybe at the end of our lecture next week, because my PowerPoint is a continuation. At the end of our lecture next week, you'll be able to get the notes, don't worry.
Okay.
You'll be able to get this PowerPoint presentation. Okay. So is there another question?
Yes, I have one.
Okay.
What would you recommend as the most preferred type of building maintenance?
Okay, but actually, I can't. There's nothing like most preferred. You know, it has to be as it arises. But well, if you want to go for planned, something something that is, you have a forethought. you schedule it and you'll be doing it every day. Of course, maybe every 2 days, so that you won't wait until you now have a, until you now have a problem at hand. So it depends on the one that is convenient for you. There's actually no preferred one. It depends on the building that you are talking about, it depends on the resources that you have, you understand? So there's no preferred. So I can't say this is preferred.
Okay, then again, deferred maintenance, should that really be said to be a type of maintenance? Because I see it as a challenge. I mean, if it's that we're supposed to carry out a certain type of maintenance and we're not doing it because of resource constraints, then should we say that's a type of maintenance?
Well,
shouldn't it be a challenge?
I understand your point, but it's a type of maintenance too. I will say fingers are not equal. You know you are supposed to do this. So also, in a way, we have a deferred admission too. You're supposed to be in school, you want to be with your mates, but because probably you are sick, probably you don't have tuition fee, you decide to defer your admission. So also the maintenance, you want to do it, but you don't have the resources to. It's a type of maintenance. So it's funny, but it's a type of maintenance too. Depending on how you look at it, it's a type of maintenance too.
Okay, fair enough. Thank you.
Yes, ma'am. Any other question? Okay. So if there's no other question, I'll start my lecture note 2. So this lecture note 2 is all about, let me say, the first 2, that is because I have a water supply, treatment, and systems of water supply. Then I have drainage system. So I can group them to be under sanitary engineering. I can group the water supply, treatment, and systems of water supply and the drainage system to be under sanitary engineering. So later, after talking about those 2, then we'll talk about transportation in building. Now, water supply. I'm very, very sure we are all conversant with water cycle. This is something we are all conversant with. So it's a revision class. You can see the figure 2 of the water cycle, condensation, that is conversion of the vapor. There will first be a condensation, then of course precipitation in form of rain. What do you understand by condensation? Conversion of vapor or your gas into liquid. It will be gathering your vapor gases, it will condense, it will bring them up together, it will convert them to liquid before you now have it as rain. And of course, when rain falls, some goes underground, some stays on the surface and all that into the ocean. Even plants, they take some, you understand? So when sun comes out, there will be evaporation, evaporation from the ocean and all that. We all know this system. And of course, transpiration from your plants back into the atmosphere. So this is just a water cycle. This is not the first time we are seeing water cycle. And it is just by the way, I just want us to know, okay, water, because we can't talk about water supply without talking about the water cycle. We all know what water cycle is. Now, we have different water sources. We have the rainwater, we have the groundwater, we have the surface water, and we have the sea water. Rainwater is rainwater. We all know what rainwater is, and we believe it is the most pure water source. We believe it is the most pure water source. Now, for our groundwater, examples of our groundwater, we have wells, we have our springs. Those are groundwater, and these are the properties of groundwater under them. High dissolved solid contents, different properties according to the confining soil. But the most important thing for you to know is that we have different water sources. That is the rainwater, groundwater, surface water, seawater. At the same time, we know rainwater stands alone. Rainwater is rainwater. It doesn't fall under any other category. Now, for the groundwater, what are the groundwater? We know wells. We have our wells, we have our springs. Those are the examples of groundwater. And for our surface water, we know what our surface water, examples of our surface water. We have our streams, we have our lakes, we have our rivers, we have our ponds. All those are examples of surface water. And of course, our seawater. And sometimes you can even classify your seawater to be under your surface water. So you can, if you still tell me that you have your rainwater, your groundwater, your surface water, and stop there, I will still take it, because you can actually classify your seawater to be under your surface water. Now, we have different water treatments. We have different water treatments because we said, aside, our rainfall is the most pure source of water. But what about other sources of water? That is our groundwater, our surface water, you know, they might have come into contact with some things that are injurious to us as human beings. So therefore, there are so many processes of water treatment, I'm sure we know. So the first one is screening. What do we mean by screening? Screening means removal of floating objects like leaves, weeds from water. Screening, or let me say CV, because it's the same thing. You're only going to be able to remove those visible things that you can see. Those bold, let me say big objects, you know, yeah, that is what you're only going to be able to remove at the screening level. Then you have your aeration. When you dissolve oxygen into water to remove smell and taste. Some water, we know when you want to drink it, you can perceive, you know, odor and all that from, you know, the water. So after screening, you aerate it, then you go through the process of sedimentation, removal of suspended matters. You know, aside from the leaves and the weeds that you've removed, there are still some matters that are suspended, you know, inside the water, whose specific gravity is higher than water, you understand? So those are it's going to pass through sedimentation. And of course, coagulation and flocculation. You know, by the time we use this common, we use alum. Alum is a coagulant. We know alum now. I'm very sure that is what we use in probably rural environments where they don't have good water. By the time you put alum, it's going to agglomerate. It's going to bring all those other particles. It's going to bring them together. It's going to, they will clog together. That is the essence of, coagulation and flocculation. That is agglomeration coming together and sedimentation of suspended solid particles through the addition of coagulating agents. We have our alum, that is the aluminum sulfate. You can also use your iron sulfate. Then, of course, filtration. You filter, that is removal of microorganisms and colloidal matter. You also have disinfection. That is, they will say this water is chlorinated, it has been chlorinated. It has been disinfected using chlorine. Of course, it has its own, you can't just pour chlorine into it. All these things are done by experts, so that it will not come back and harm the users. So disinfection in terms of pre-chlorination and dechlorination to remove algae and to remove bacteria. Then lastly, some water needs to be softened. There's something we call hardness of water. When you're trying to lather your water with soap and it's not forming soap easily, your soap is not forming lather easily, you say that water is hard. So what do we understand by hardness of water? It occurs when calcium or magnesium salts are present inside your water. And what is the effect of this hardness of water? You'll see if you have a kettle, and probably you'll be using that kettle to boil water. Some kettles, by the time you pour water away from them and you remove them, you look inside, you are going to see some sediments, inside your kettle as a result of using it to boil hard water over time. You are going to see scale. Those are the effects of hardness of water. They will, by the time you are using your kettle to boil hard water, it will be causing the deposit of calcium carbonate, your CaCO3. It's going to be deposited at the bottom of your kettle. Over time, you are going to be seeing scales inside your kettle. It can even block pipes. It can spoil water heaters. That is water hardness. And it occurs when you have calcium and magnesium salts present inside your water. So to remove it, you have to soften your water. Now, we have systems of water supply. Now, I can say, okay, let us first define it. Systems of water supply. What do we mean by systems? Systems of water supply. That is a system that carries water from the water source or street main to the building, and from the building to various points in that building at which you can take your cup and collect it, or use it directly. That is what we mean by systems of water supply. Now, we have two water supply systems. Majorly we have cold water and we have hot water. What's the difference between cold and hot water? For hot water, there's a boiler. A boiler has been introduced to heat up cold water, and that is when you say, okay, this water is cold and this water is hot. You understand? So when you're talking about types of cold water now, I can now say we have direct system of cold water. I'm going to explain, and we can say we have indirect systems of cold water. Also, talking about hot water, because you've boiled this, you've introduced boiler, your water is now hot instead of cold. You can say you have direct system and you have indirect system. So actually, if I want to put this direct and indirect together, I can now say we have 4 types of systems of water supply. I can say, because each one has direct and indirect. Under cold, I have direct and indirect. Under hot, I have direct and indirect. So I want to put them together now. So I can say I have direct system of cold water supply, indirect system of cold water supply, direct system of hot water supply, indirect system of hot water supply. Now, another thing we should look at is, what do we mean by direct and what do we mean by indirect? So the direct means that is water is supplied directly from the mains to the fixture. You are not reserving it, you are not storing it anywhere. It's just from your main, and you just go to your tap and open it. But by the time your water gets stored in an overhead tank, before it is now being moved to different floors, then you have an indirect. So I'm sure in most houses, we have indirect water supply system, because definitely we first store, after pumping it, we first store our water in tank, you understand, before we now, before it is now being supplied to different floors in our building. So for the systems of water supply, we know water can be cold or water can be hot. Hot because it has been boiled up, there's presence of boiler, and most times hot water supply is used in areas where they have hardness of water, areas where they know it has been confirmed that in this area, the only water you can get here is hard. Then you have to make sure you use what? Hot water supply system, so that at least you have boiler that will be boiling up the water, softening the hardness, preventing your pipes from being clogged, preventing your pipes from being blocked, preventing your pipes from bursting. So this is mainly used in areas where it has been confirmed that they have water hardness. So water can be cold, water can be hot. It can be direct if we are not storing it inside any reservoir. We are just taking it from our mains to our fixtures. It can be indirect if it has to be pumped from the ground, stored in our overhead reservoirs or overhead tanks before being distributed to our different floors, indirect. So the only difference between direct and indirect is one does not, you don't need to store it. Just more or less like pay as you go. You are not storing it, you are just using it. But if you have to store, probably you don't trust, you know. If you have to store for any reason, then it means you are operating an indirect, you know, water supply system. Indirect water supply system. And if you, by the time you open your water and you are getting cold water, so it means you are operating a what? Indirect system of cold water supply. So the most important thing here is you understand what it means to be direct, you understand what it means to be indirect. So you can actually now put them in the cold water and the hot water. Water can either be cold or hot. Cold, hot because it has the presence of boiler. It is eating it up simply because you are trying to work against what? Hardness of water. If you don't have any problem in your area, you know, you don't need to heat up your water. You don't need to boil your water. You understand? So that is that about. Now, before I go to drainage system, do we have any questions? Okay, no, okay. I still have one more slide on direct water supply system and its disadvantages. Then indirect water supply system. Now, whether it is cold or hot, we know that one. But now, direct. And you know, I said you have to note the difference between direct and indirect. Why do we have to call one direct and why do we have to call one indirect? We are calling it indirect, just as the name implies. It is not coming directly. It has already, water has been pumped, it has been stored in your reservoir or in your overhead tank before it is not being distributed. So it is indirect. Now, what are the difference between direct and indirect? The advantages and the disadvantages. You know, look at this indirect. Indirect water system, there's no risk of back siphonage with this system. There's no tendency of pipe bursting due to the low pressure in pipe work. In case of any interruption in the main supply, there's adequate store of water. That is, you've already stored your water, you know. So whether there is light or there is no light, you can always get your water because you've already pumped it inside, you've already pumped it into your overhead tank. And another thing is because you are using a machine to pump, you know, your water, except your pumping machine has problem. Okay, do you have a question? I can see a hand. Okay. I can't hear you. On mute, I can't hear you.
Okay, ma. Can you hear me now?
Yes, I can hear you.
Okay, ma, as a rural man that have a well in my house. Can you hear me?
I can hear you.
Okay, I said as a rural man that have a well in my house with some pots attached to the well or parked near the well.
Okay.
So immediately I fetch water from immediately I fetch water from the well and pour them in the nearby pots.
Okay.
And start fetching the water from the pot. Can I call that direct?
Can you call that
or
direct?
If I need water, direct.
I'm listening to you.
Direct cold water. Then, if by virtue of my rurality that I can only use firewood to warm the water.
Okay. I'm listening to you.
So, please, before we proceed.
I'm listening. You were saying something about
that's my question, man. So, by firewood. I said as a rural man that I don't have all these gadgets in my house.
Okay.
That I have to use firewood to warm the water. Okay. So by the time I boil the water using firewood, can I call that one as indirect? So I need some explanation, ma.
Well, with your kind of okay, boiling the water. Okay.
Yes.
Okay, let me first start. Boiling the water has nothing to do with is it direct or indirect. the direct or indirect has to do with the first part of your question that says you have a well and you are storing it in pots outside, Abby. So sincerely, I can say you still have a direct water supply system. It is not indirect.
Okay.
It is a direct water supply system. Now, if you're not using firewood to boil, that is what I, okay. If you're not using firewood to boil.
Now you, okay.
Please continue your question. Let me hear. You wanted to say something.
Yeah, I'm saying using this very example, man. Now, where does the question of indirect comes in?
Okay. So let me go back to that slide. This is the slide. You know, the direct says water is supplied from your well to the point where you will take it.
Okay, that's the pots.
That is the direct. That was why I said the kind of system you're operating is a direct water supply. And I'm sure that water coming from the well is cold. Is cold water now. So I can say in your house, and that's your rural house, you are operating direct system of cold water supply.
Okay.
Now, if it is indirect, it means that water from your well is being pumped to an overhead tank, our reservoirs. Then it is now supplied to different floors by gravity, by gravitational force.
I see. Okay.
So hope I've been able to answer your question.
Yeah, wonderful. Thank you, ma. Thank you.
Yes, sir. So back to this slide, the indirect water supply system. That's what I started talking about, because what is the direct is just the opposite of indirect. Because under the indirect, because we are using overhead, definitely we are using pipes. And those are the disadvantages, because it uses longer pipes are being run, because you have to use pipe from your well, connect to your tank, from the tank to different floors of the houses. So those are part of the disadvantages of using indirect water system. Longer pipes runs are required. A larger storage tank is necessary. A larger storage tank is necessary. Then the last point is not, well, it's the last point that says fresh drinking water is only available at the kitchen sink. Well, you won't want to take water from the bedroom. Fine. Despite the fact that we know that it is still the same water coming from the same tank that is being run around the house. If we want to drink water, we can't go to the bedroom and take water from the bedroom. I hope you understand what I'm saying. It's the same water coming from the same tank, but because the point where our fixture, we have one fixture in the kitchen as tap, we have one in the bedroom, we have one in the toilet. We cannot go to the bedroom and say, okay, let me take my cup, let me go and take water from the bedroom. Simply because that fixture is in the bedroom, we can't drink water from there. We will either prefer to go to the kitchen and take our drinking water. So for the direct water system, of course, because you are not using you are not using any overhead, so you are saving money in pipe works. You don't need any serious pipe work, and because it is direct, just like the question he asked the other time, from your well to your pot, you can obtain from your well to your pot. You are not putting fixtures everywhere, and so. However, if there is no, like for example, disadvantages during peak period, there is tendency, if you're not the only one using that well, during peak period, that is when people are many on that well, of course, you might not be able to get clean water, because so many people already, if you're not the one, except you are the only one using that well, you understand, then you can always go there morning, afternoon, and night, and you get your water. But if in the situation where you have so many people using that well, Probably in the morning, people will quickly come out and fetch water from there. You understand? The water will still be clean. By the time there's pressure on the water, you know, the water will start changing colors and all that. And also, you don't really have somewhere to store your water. So it can be a challenge. It's just the difference between direct and indirect is just word and opposite, which I want us to go back and read more. So before I start drainage system, he has asked this question. Is there any other question before we now start the drainage system? Question, if you have a question, you can wave your hand. Do we have a question? Okay, so if there's no question, the topic 5 is drainage system. You know, I said for our water supply, treatment and all that, and drainage system, the two can be categorized under sanitary engineering. So we are done with the water supply, water treatment, and, you know, the systems of water supply. So we are talking about the drainage system now. Like I said, this is something we all know. So drainage system, it refers to all piping within the private and public premises, which conveys sewage, rainwater, and other liquid waste to a point of disposal. Drainage system. We are talking about water that we did not use. Water that we did not use. You know, for example, probably when we are washing in the kitchen, we are washing our plates inside the sink. You know, we are washing, we open tap, we are washing plates, the water is going somewhere. Automatically, after using the water, it has turned towards a water that cannot be used. And I'm sure it goes into our manhole. Then from there, connected to probably I don't know, probably you have the gutter or the kind of drainage system you have in your house. So drainage system refers to all pipings. Don't forget, water, the used water is coming from the kitchen, used water is coming from the bedroom, from the toilet, all those water that we don't use or we've used, you understand? Because there are sometimes that we waste water. You know, that water is not that water that we waste. If we just open tap or our children are playing with water, they are not going back to the reservoir. The reservoir, our overhead tank cannot get that water again. It automatically becomes a waste. So it's going into our drainage system, whether we use the water, whether we don't use the water. So drainage system refers to all pipings within the private and public premises, which conveys sewage, rainwater, even rainwater. When it is raining, we collect some goes to the gutter, some goes to the sea, some will still, you know, they will just run off like that. It is not all this water that we tend to use. Now, we have different types of drainage system. We have combined system, separate system, partially. It is just as the name implies. And that is why I highlighted some words in red. Combine, you know, combine. You are joining two things together. That is, combined system, you are using a single drain to convey both foul water from your sanitary appliances and rainwater. It's combined. You are using just one single drain. That is, inside this single drain, that is, you have a single drain, your foul water coming from your bedroom, from your toilet, plus the runoff from the rain, they will merge at a point and they will get drained inside this single drain. I hope you understand what I'm talking about. And because you are using just a single drain system, which is a combined system, you know, you are not separating the water coming from your toilets, you know, from your sanitary appliances. You are not separating it from water coming from your roof during rainfall and all that. You are not separating them. You are collecting them together. That is why we are saying it's combined. Of course, it is economical because you are using lesser pipe. You understand? It is economical to install. You are really not going to use so much money. But when you are talking about a separate system, that is okay, I can actually afford it. I don't want them to come together, probably due to volume. You understand? You don't want them to come together. You have the resources, probably due to the volume. So you are trying to separate water coming from the foul water. It's foul because you know how water coming from the bedroom, coming from the toilets, coming from the kitchen is going to be. So they're now separating your foul water from your rainwater. You know, this is going to use this particular pipe set. This is going to use another particular pipe set. So you have two separate sets of drain, just as the name implies. So combined means you are using a single drain to convey both your foul water from the sanitary appliances and your rainwater. You are using just one single drain to convey them to a particular sewer. But for separate, you are using a separate drain for your foul water. You are using a separate drain for your rainwater. They are going differently. It's actually more expensive, just as the name implies. Now, the third one is partially separate system. That is for convenience and to reduce site cost. You know, the local water authority, I actually don't know if our local water authority functions in this country, because they are supposed to oversee, you know, how we connect and that is why if on our street, you see how people connect and how people dispose of their, you know, their wastewater. Someone's wastewater is going to be disturbing another person in his house and all that, simply because we don't have authority to oversee how we do or how we separate our wastewater. You know, so for the partially separate, as the name implies, you know, you actually have two different drains, but you have one for foul, you have one for rainwater, but you're actually diverting part of your rainwater to go and meet the foul. They are not independent. They are not totally independent of each other. You know, for convenience, you know, you're allowing your rainwater to meet part of your rainwater to meet your foul water. You understand? It is not completely separate. It's a partially separate system. But like I said, we know we have these different types of drainage system. However, I'm very sure they are not being monitored, because how many houses can even boast of, you know, water supply and all that in their environments? Nowadays, we do things our own way. So I don't think they actually get to monitor how we go about our drainage system. So those are the types. You have to know the types of drainage system. We have the combined. Combined means you are using one single drain to take both your foul water and your rainwater combined together. Separate means you are using individual. This one has its own, this one has its own. Then partial separate means, fine, the two has its own, but you're actually taking one from here, half from here to join one. You understand? So that's about drainage system. Now, transportation in building. Transportation in building. We will soon be rounding off. Transportation in building. Transportation, we know these ones too, because, you know, we work in organizations that has different floors, and we have to, you know, we have to move from one floor to another. Some of us, we cannot go through staircase. You understand? Simply because the stress and, you know, depending on what floor you are working on. So transportation in building, there are forms of mechanical transportation that may be found within, around, and in general. In fact, you can find all these types in modern buildings. You know, we have lifts. I'm sure we all know what lifts are. We can call it lift, we can call it elevator. I'm sure we all know. So I'm not going to be dwelling so much on what is lift, because we all know, if a lift is common, we know lifts. Now, aside lift, we have what? Escalator. Escalator, when we go to ShopRite is a good example. Or let me say our shopping mall. Our shopping malls are good examples of where we can see escalators. You know, that thing like stairs that you just stay on and it's going to be moving you upwards. That is an escalator. It's everywhere in our shopping malls. I don't think that cannot be found in, let me say, an organization, or it can only be found in public places. So escalators are moving stairs used to convey people between floor levels and all that. So, and travelator. I was actually telling someone that this travelator, I don't think it's here in Nigeria. I don't know. Probably some parts of our country, probably we have travelator, but I've not, I've not seen one here in Nigeria. It might be, I don't know. But so, aside from lifts, we have escalator, we also have travelators. It can also, the travelators are also known as auto walks, passengers, conveyors, and moving pavements. Unlike lifts that transfers people vertically, travelator transfers horizontally. They provide horizontal conveyance for people, luggage, and all that. And of course, even all these things we are talking about, starting from escalators, and they have an angle of inclination. For escalator, for example, we said it is normally at an angle of inclination of 30 degrees, which may be increased to 35. Imagine if you now increase it to like 50. In fact, people will be falling from it, because instead of it to be inclined like this, it's going to be steep. You understand? So all this, but I can tell you that the most important thing for you to know is to know the different types of transportation in building. We have lifts, we have escalators, and we have travelators. Thank you. And this brings us to the end of this class today. So, questions?
Excuse me, ma. Hello, ma.
Yes, sir.
Please don't mind me. Really, I'm a rural man. Please, part of this transportation in buildings.
Okay.
Yeah, we made mention of lift, escalators, and travelators. What of the normal manual procedures we do use in climbing our upstairs here in Nigeria that is common? I think it should be part of them.
Well, we are talking about modern buildings.
A modern building, okay.
Yes, within, around, and in general association with modern buildings and developments.
I see. Thank you.
So we are talking about modern. Please, is there another question? Thank you, sir. Is there another question?
Yes, ma.
Okay.
If you're on the line, yes.
Okay.
Ma, can we get this slide? Is it possible to get your slide?
It's not a problem, but I said I will give us the slide after this class. We have another class on Tuesday, 4 to 6. So okay. Don't you think I should compile the notes together so that I'll be able to give you once and for all?
Okay,
it's better,
understood. It's fine.
So I will do that next week. Okay, you're welcome. Any other question? Okay. So if there's no other question, I want to believe to a great extent, we understand or we have great knowledge, in-depth knowledge of what we talked about today, which I'm sure there are simple things that we can all sit down, and actually go through. But while waiting for my slides, you can actually start with your study pack so that at least you have something to read and to fall back to. But I promise I'm going to give out my slide by after next week lecture by God's grace. Thank you. So that ends the class. Thanks for coming.
Thank you, ma. Thank you for the lecture.
Sorry about last week. I'm so sorry.
Thank you, ma.
No, Wahala. Thank you. Today was much better. Thank you.